Hey, chemistry. If you missed class today, we talked about properties of materials and different types of bonds between atoms. For a warm-up, I asked you to think about two different materials that you use every day and describe the properties that make them useful. I gave you an example of glass. So we have glass on a lot of objects. Our phones have glass, our ovens have windows, our houses, our cars. And the reason we use it is because it's clear, you can see through it, and also because it's solid and it's stable. It does not dissolve in water like some other clear solids, like a salt crystal maybe. Another example of a material we use every day would be like metal in our pots and pans. So the reason we use that is because it heats up quickly, but it doesn't melt. Right? We also want it to be a solid so we can have it in a specific shape. It's also important that it doesn't dissolve in water, otherwise we wouldn't be able to boil any water. So, the reason we use metal to make pots is because it heats up quickly, but it doesn't melt. It's water stable, and it's solid. So, we're trying to think about the larger question, why do substances have different properties? There are 118 elements, each which have their own property, but there are thousands of different types of material. So, why do different materials have different properties? We ended up skipping over our KWL chart because the power was blinking a little bit and I was actually worried we were going to lose the call. So we skipped that and started here. This is a picture of graphite and a diamond. Both graphite and a diamond are made out of mostly carbon, but graphite is one of the softest known materials, where carbon is the hardest known material. So, what makes these two materials different? We started talking about what is a chemical bond. So a chemical bond is an attraction between atoms that results in a molecule, and once they're bonded, atoms are usually more stable. Most of you realized when you did your element project that your element was not usually found as a pure metal or nonmetal in nature. Usually they're found mixed with something. And the different types of bonds determine the different properties of the materials. So as a review, trying to remember which side of our periodic table is more electronegative. Nonmetals are more electronegative, meaning they pull electrons from other atoms. Metals are more likely to lose an electron during a chemical reaction because they have one or two in their valence shell and are willing to give them up. So there's three different types of bonds we're going to talk about, and the type of bond depends on the type of atom involved. Bonds can be between a metal and a nonmetal, two nonmetals, or two metals. So if you combine a metal and a nonmetal, there is a big difference in electronegativity, so atoms are going to give up electrons, whereas nonmetals are very strongly going to attract them, and that's going to resolve in electrons leaving the less attractive atom and going to the more attractive one. And here's an example of that. The sodium gives a metal to the fluorine. As a result, the sodium is positive and the fluorine is negative, and those two charges stick together. This is called an ionic bond, and it's named an ionic bond because both of these species are ions with their charges, and that charge difference holds them together. These bonds are very strong and usually result in a very solid and regular repeating structured crystal. So, ionic molecules have a usual repeating structure, usually forms a crystal. They have a very high melting point, and as a result of the molecular structure, they are hard and brittle. They're usually soluble, which means you can usually mix them in water, and when they are liquids, electricity can flow through them. We'll come back to more on that in the second, or we'll come back to more about conducting electricity when liquid in our assignment on Wednesday. An example of an ionic molecule is salt, also known as sodium chloride. If two nonmetals bond, there is a small difference in the electronegativity, so both of them strongly attract the atoms. As a result, the electron is going to be shared between the two of them. And here's an example. You can see each hydrogen atom has one electron, and then when the electron clouds overlap, they share, and the electron is going to stay between the two nuclei. These are called covalent bonds. Covalent bonds are formed between nonmetals. And properties of covalent bonds are pretty much the opposite of properties of ionic bonds. So, covalent bonds can be liquid, solid, or gas. They have low melting points. They're usually not soluble in water. They don't conduct electricity, and they might be flammable. A good example of a covalent compound would be fats or oils. The last type of bond is between two metals. Metal ions have low electronegativity, so they do not strongly pull on electrons. As a result, the electrons float around, not really associated with either atom. And this is an example of what that would look like. We have our positively charged nuclei in regular spacing, but the electrons are sort of floating around. It's called the sea of electrons model. This is one of the reasons why metals are such good electrical conductors, is because they have all these electrons moving around, which can allow electricity, moving electrons, to flow more easily. Properties of metallic compounds, these are metals, so they have a high melting and boiling point, which means they're usually solid. They conduct heat and electricity well. They're also hard and dense, but unlike ionic compounds, they're not brittle. So when you hit something metal with a hammer, you can bend it. That's malleable. Or you can stretch it into wires without it ripping, and that's ductile. So metal is all of those things. So, back to this. Both graphite and diamonds are made from carbon. Why is one soft and one is hard? Well, those carbon atoms are held together with different types of bonds. So in the activity that we do tomorrow, you're going to investigate the difference between salt and sugar in a virtual lab. If you have any questions about any of that, please send me an email or come to office hours. Bye.